Let's sit everyone and we start again. And we keep on this theme of academy and industry together, and this time you're in for a treat because we will see how to apply these methods to elections and other interesting social science aspects. We have today Corrado Monti from Sentai that will talk about interpretable computable models of social behavior. Thank you, Corrado.
Thank you very much. Thanks for the introduction. Thanks for inviting me here, and thanks to Andre for the awesome talk, which also is a good introduction. And my talk will be about computational models for social behavior. First of all, like a very few words on who am I, what am I doing here. I'm a computer scientist by training. Did my PhD in Milan, and I started applying machine learning not in my bachelor as Andrea, but in my master. So I arrived a little bit later, and that was in 2012. So I did some postdocs around. I have some experience in the industry. I also did a startup in Berlin. It's crazy how everyone has an experience in Berlin in machine learning. And now I'm a researcher in Sentai, which is a private institute in Turin. My focus is on social behavior, and I'm always trying to apply machine learning models to social behavior, social science questions, and that's something that I've been trying to focus on since the very first start of my career. And now I'm a researcher in Sentai, which is a quite novel company that was started 2 years ago. Just a few words is that we are trying to mix academia and industry in a pretty non-standard way. We have some mixed backgrounds from computer scientists, a bunch of physicists, of course, mathematicians. We have some economists that help us with economical models, and we are trying to do this thing where we mix fundamental research and applied projects with industrial partners. The idea is that we have a bunch of time to do foundational research, and then we try to apply the state-of-the-art methods to industrial projects with partners that come to us and ask a scientific approach to their problem. So this is nice because I have a vantage point of both worlds. So I see why Andrea was telling about academia. Also true that also in the industry there are some dinosaurs, and I think that we all are pretty aware of that. So after this short introduction, I will start with my talk about machine learning models for social behavior, and in particular, I will start from examples of how can machine learning help in addressing social science questions. So I will start from some examples of social science questions that can be answered with machine learning. And my field of expertise is social media, so these are all kind of related to social media. I think that social media are another like crazy thing that happened in the last decades. So we are still trying to understand what are the consequences of this new world. And I will start from Donald Trump. This I will get there. Work with me. So Donald Trump was the winner of the 2016 elections against Hillary Clinton. And the interesting fact is that, as in this newspaper, he was described as an underdog. So it was a surprising win. And there have been a number of articles saying that Donald Trump won't win even the Republican nomination, not even the elections. So it was a huge surprise for a lot of people. Trump, according to the Washington Post, he was due to flame out. This was from 2015, and so on and so forth. Why was this so surprising? I'm not speaking a microphone. Now I am. Okay. Because Donald Trump was no conservative, according to some journals, some newspapers, or he was a counterfeit Republican. So the question then is, who supported Donald Trump? Like, was he a counterfeit conservative, as newspapers said? Where was the supporters coming from? And that's where we try to bring some data science and some machine learning into this. We took the subreddit from Donald Trump supporters on Reddit. So Reddit, I'm pretty sure that how many of you know Reddit? Like, I've ever. Oh, okay. I will skip the presentation then. So Reddit is one of the most popular websites in the United States. I think the fourth or something like that, most visited, and is organized in forums. One of these forums was the Donald, which was created by Donald Trump supporters for Donald Trump supporters. And so you basically you would get banned if you post something against Donald Trump. So it's a pretty clear indication that someone is a Trump supporter. This subreddit had hundreds of thousands of users, at least on the election day. Then it got banned after some years due to conspiracy theory and spread of violence, but that's another story. Anyway, it was created to support Donald Trump campaign. So we can use this subreddit as a target for a machine learning classifier. That's the key point here. Let me show you how. The idea is that by doing this, we will get clues about where are these supporters coming from. So, and specifically, we will try to look at those supporters from the point of view of 4 years before. So, at the previous election cycles, where Donald Trump was a TV star, not a candidate for president. So we treat this as a computational focus group. We built this computational focus group with politically active users on Reddit in 2012. So users that were participating to political forums. This ended up in being some tens of thousands of users that were active both in 2012 and in 2016. Of these 44 active users in politics, 7,000 turned out to be Donald Trump supporters, so participated in the Donald Trump community. So, as you can imagine, the question now is, okay, if we look at the features of these users from 2012, what can we see in those users that will allow us to predict if they are Donald Trump supporters or not? So 4 years later. So of course we're doing this in hindsight, but using only features that were extracted from 2012. So in particular, we are using the text from comments. As you can imagine, that's easy. TF-IDF, as Andrea explained. We are using the communities of these users, which, like the underlying mechanism is homophily, so birds of flocks of a feather goes together. So people that belong to the same community are likely to have the same behavior. And then we are using scores, so upvotes and downvotes on Reddit, interactions of these users, and these are our features that we gather from 2012. So with these features, we predict if a user will turn out to be a Trumpist. So we measure the results. We have a train set, test set, and so on, and we measure their and their curve. Turns out that with combining these features, you can get to 70% of area under curve, which to me it was pretty surprising, because it's a fairly good prediction considering that we have this huge time lapse. And in particular, it's interesting to note that the communities are by far the most predicting feature here. The text is not as predictive. The communities are telling you more about these users than what they actually write. So naturally, to answer our social science question from earlier, we are interested in, okay, but which communities are predictive? And so these are the communities that are most predictive. So all of these, since we're looking at a very big data set, all of these are statistically significant, according to the usual definition of statistically significant, whatever, even if you don't believe in that. And but still, those are the features that allow you to predict. I will speak a bit about this because it's super funny. So. So these are the most predictive features in Donald Trump supporters. So first of all, okay, let's start from the serious stuff. So first of all, we can see that the most predictive features here are political groups. So the most predictive feature of them all is conservative. Like these are people that 4 years before were conservatives. And the second most predictive is libertarian, which is clearly one of the ideologies that were mixed in the Donald Trump supporters community. We see anarcho-capitalism in there as well, pretty high. This echoes some theories from social science. There is this sociologist called Wendy Brown that is speaking of libertarian authoritarianism as a way to describe Donald Trump ideology. This idea of I'm rich, I should be doing whatever I want. But we can find others. We can find conspiracy. I think that this is not particularly surprising for many. Like Donald Trump used the QAnon conspiracy theory to spread in society. There are others that are probably quite logical, but a bit more surprising. Like these two communities, 4chan and I'm going to help for this, which, I mean, maybe some of you know what 4chan is a terrible place. And it's particularly noted for shock humor and this like black humor, tongue-in-cheek humor that apparently 4 years before was a predictive characteristic of the, I'm assuming, teenagers that developed to be Donald Trump supporters. The interesting thing is that there is a lot of sex-related communities here. We have, of course, there is some men's rights, which is an anti-feminist community that is among the most important. There is seduction, which is another community for like so-called pick-up artists, and that's also predictive. It's interesting to note, and I cannot not notice that there are two communities that are related to some kind of sexual issues, like NoFap, which is for addiction to masturbation, and Dead Bedrooms, which is self-explanatory, I think. Yeah, so if we look at the most predictive communities for non-Donald Trump supporters, we also find interesting stuff. Thank you for that. The most predictive communities for non-Donald Trump supporters are also like interesting to look at. It's interesting to see that there are no political communities here. Instead, there are also some sexual communities here. You have LGBT and polyamory that are among the most predictive for non-Donald Trump supporters, as maybe someone can expect. In the Donald Trump field, you have some religious community, while in the non-supporters, you have true atheism as a counterbalance, let's say. We also noticed that there are Raspberry Pi and this thing. I don't know why Raspberry Pi was the most predictive features, but I can believe that. And yeah, there is a nice paper that is called Why Liberals Drink Caffè Latte that is delving into these weird correlations that emerge when you analyze this kind of stuff. But still, I think that we got a pretty interesting answer to our question from the start. Another question that one might want to answer is who are right-wing users interacting with? So we know that there are Donald Trump supporters on Reddit. Like, who are they interacting with? And who are left-wing users interacting with? And that's another thing that we can explore using a machine learning model. A statistical model, like to be precise. So there are different hypotheses in who interacts with whom on social media. I think that this is a very hot debate right now. Like if there are ideological echo chambers where everything that you see on social media is just reflecting your own opinion, and you never see anyone fighting on social media, and that was the most popular view until some years ago, surprisingly. And another hypothesis that has been made is that instead the demographic factors and not the ideology is what is creating echo chambers on social media. So there are demographic groups that do not talk to each other, and each demographic group is reinforcing their own identity. This is somehow correlated to their ideology and through material conditions of different demographic groups. So we compare these two hypotheses still using Reddit. I will be using Reddit a lot in this talk. So in this case, we picked the news discussion subreddit that is like the I don't know, the second or third most popular subreddit, and it's kind of neutral, so it was a neutral ground to test on. And we measured the interactions among users on this subreddit over 5 years, so from 2016 to 2021. We extract one network, so we connect users that are interacting with each other, and we obtain a different network for each year. Each of these networks has tens of thousands of users, millions of interactions, so it's a pretty good sample. For each of these users, and this is the nice thing, we can have an estimate of the probability that they belong to some demographic groups. So as I showed you before, it's easy to say if a user is a Donald Trump supporter or not, looking at the subreddit that they participate in. You can extend this concept, and it has been done in this other paper to other traits of a user. So we picked these 4 that are the age, distinguished in young and old, not more fine-grained than that, gender, male and female, affluence, rich and poor, politics, left and right. So this is very coarse-grained, not super complex. And to be even more sure of what this is getting us, we are picking just the users for which this is more likely. So the top and the bottom of each of these axes. And so what we obtain is a graph, like a network, where each user has some of these traits. And what we are asking is, okay, this is not important. Okay. What we obtain is a network where these users these communities are partially connecting, and we want to find out how they are connecting. To find out that, we used a probabilistic network model that we trained a model to predict whether there is a connection or not based on the features, on the traits of the 2 users that we are considering. This can be expressed as a matrix, which is this matrix W, and each row and column corresponds to how much these 2 traits are interacting. So more specifically, the log-odds ratio, so the how more likely it is that interaction compared to a null model where these features do not appear. So if we fit this model to data, what we obtain is this matrix where we have our 8 attributes on the rows and on the columns. And this will be more red when the interactions between these 2 given features are more frequent, and blue when they are less frequent than the null. So the interesting thing here will be on the diagonal, is young interacting with other young users more often or less often? And so anybody has any guess on how red or blue the diagonal will be? So more likely or less likely, which is the different pairs. I will show you them. Whoops! I destroyed the suspense. So this is what happens, and this is valid for all the years that we've considered, which is surprising. What you see is that the diagonal is mostly red. So mostly different groups are interacting among themselves, except the last 2, left and right, are blue, which was super surprising for some of my colleagues. But that's what you see when you measure this in this data. What does this mean? That you have these features that are, we call it homophiliac, so where the same group are speaking among themselves, while you have these other features, so left and right, that are heterophiliac, so they are interacting among different groups more than what they are interacting within the groups. So in other words, we can see that the demographic features are separating users, while the political sides are actually interacting with each other. Of course, they are mostly fighting, but still, that's how a debate is performed. So just to be super sure, we double-checked if it was a result of different topics. We tagged each interaction with a topic. I'm not going into the details, but we added the topic to the model, And what we obtain is still the same matrix, that even more clear. Like you can see that even if you consider that different groups are interested in the same topic, still there is interactions are still like segregating by demographic, even if you take that into account. Of course, you also obtain as a side product this interesting matrix of demographic groups and the news topics that tells you, for instance, that the most interested people in technology are rich people, which is something that it's always interesting to keep in mind. We saw that thanks to this machine learning model that different sites interact with each other. Like, what does interaction lead to? Are these interactions opinion changing? That's where we applied another machine learning model based on natural language processing, this time with another Reddit community that is called Change My View, which is a great natural experiment for this kind of stuff. Where a poster proposes a stance, in this example, the fact that legislating AI is useless. And then there are commenters that commented and try to change the view of the original poster. And the interesting fact is that they tagged the original poster says delta with this precise word when the comment made them change their mind. So this is super precious as a scientist because you can scrape for that and you find exactly the comment that was opinion changing. So what we did was to scrape everything, and we got some tens of thousands of posts and some millions of comments, of which 38,000 were opinion changing. So again, this is a naturally a binary classification task where we can ask what is the language of these opinion changing comments. We did this again thanks to with an interpretable model. We did it interpretable through social science using these social dimensions that are like within a well-defined social science framework, and that distinguish the different intents of communication. So, for instance, the intent of communication can be knowledge, meaning exchanging information, power, status, and so on. We trained LSTMs with this, and what we obtain when we try to classify opinion change is this. So, first of all, it's interesting to note that if the message has a social intent, then you see that it's more likely to be opinion changing. But the most interesting fact is that the more likely to be opinion changing are the messages that convey knowledge, similarity, and trust, which is comforting, at least to me. Like a message with knowledge, almost that was identified to have the intent of transmitting knowledge to the recipient, is almost double more likely to be recognized as opinion changing. And similarity is also almost doubling. This is nice because it echoes some like the philosophy of Jürgen Habermas, which was a philosopher that studied effective communication, that identified effective communication as being characterized by shared knowledge, mutual trust, and accord with one another, which is echoing these results significantly. So, okay, I hope that I convinced you that there are machine learning models that can help in answering social science questions. This is like the purpose of this first part of the talk. Now I'm trying to tell you a bit more about the how. We've seen that they can, but are there ways that we can further develop machine learning models to make them more useful to answer social science questions about the human behavior? And this brings the question of what is a model. That's a very general question, but let's think that social scientists also have models. Like social scientists have been developing models that are a way to encode their interpretation of reality. So they have this. It's of course they are not physical model. They're not formal. They are often not super mathematical. But still, like this is it's what is being known as a model. We have models too. We have Keras models. That's our definition of model. So we have a thing that sees data and learns some mathematical patterns. Okay, the natural question is now, like, how can these two talk to each other? And one of the answer is agent-based modeling. Agent-based modeling is has been born in mostly in economy, but has been being used also in biology, in epidemics. Like in epidemiology, has been used a lot to forecast the spread of diseases, also in the COVID pandemic. And it's a way to encode some assumptions about the behavior of some agents and make simulations out of them. So there are some fictional agents that by simulating them, you get the information about their behavior. So how can we make this model learnable? That's the question. Like, these models are made for simulations. They're not made to learn from data. Of course, so you need to calibrate them, and you also are using them to do predictions. So it would be interesting to make them actually learn from data. And this is what I've been doing in my research recently, like trying to connect these two words. What I'm showing here is a very simplified representation of what a neural network does, right? You have some input, neural network processes based on their parameters, gets a prediction out. This prediction is compared to their output, and you have a loss, backpropagation, and that loss tells you how to change the parameters of the network. Okay, so far so good. What, for instance, an example is that you can give an image of a cat, the neural network says dog, then the loss tells you, no, this is not a dog. And so the parameters get changed and adapt to the answer. You can do a similar thing that fits in the precise same schema with agent-based modeling. You have a current state of the system. So, for instance, the position of users or of agents that could spread a disease. You have a model that tells you how this should evolve according to some parameters that maybe you don't know. Like, for instance, is this user infected or not? Maybe you don't know that. You need to estimate that somehow. You get a prediction out of that. And the nice thing is that you can compare this to a given data set that tells you a history of what happened. And in this way, by using the same mechanism, so by using the likelihood, maximizing the likelihood with gradient optimizations, with Keras and so on and so forth, the same machinery of neural networks, you get an update to the parameters of this model. But the interesting difference is that in this case, the model is interpretable. You can have, like, for instance, in an economical model, you can have the employment, you can have the demand, and how these things are interacting with one another. And that's the model that you are optimizing. So this is a kind of a probabilistic model. And if you compare this to the standard neural networks, instead what you have is, as XKCD put it a while ago, it's a pile of linear algebra that you stir until it's right. So there is a fundamental difference between these two approaches, which is also related to the question that asked, I think you, like, there is a kind of a philosophical difference, if you want, in the fact that this is interpretable. This is something that tells you something about the world. So I'm giving you a last example, and maybe how much time? 5?
I bet you can go.
Okay.
But you can go more.
I don't know if I'll do that. That's a responsibility. So you can apply this, for instance, to opinion models, like opinion dynamics model. For instance, this is a bounded confidence model, which is a very simplified model of how opinions evolve. That tells you simply that two users, two individuals, two of us can converge in their opinion if they are closer than a certain threshold. And you express this numerically. And you can also have backfire, which is a controversial concept that it's hard to understand if it's real or not, but which means that if two users are further than a certain threshold, then they are spreading apart instead of getting closer. The interesting thing is that you can make this agent-based model learnable. So you can devise a likelihood and maximize that likelihood from this model and obtain some estimate of their parameters. You can do this once you have observed data. So we consider this users on a social media, and we considered actions like being part of a community as a proxy of their opinion. We feed this model to data, and what you see is that when you feed this model to data, the distance between the opinions that have been estimated is correlated with the amount of likes that these users get on the community. So this model is learning something that makes sense. This model has never seen the likes, the score. Still, the results that it gets are correlated with that. That makes sense. That is telling us that this model picked us something from reality. We can do this even with way more complicated agent-based model like this one from economy, that is a model of the housing market, where basically you have agents that are like buy and sell houses. They belong to a certain income class. And what you observe is just that a certain house is being sold at a certain price. And what you don't know is what is the income level of the agents, where is it? You can estimate that. And this, of course, you need to make this learnable as well. You need to devise a likelihood. This is the probabilistic model. That is, if you are familiar with the probabilistic model, you see immediately that this is very weird as a probabilistic model because it's an agent-based model. It's a lot of chain. It's a very long chain of equations, which reminds of deep learning models in a way. Anyway, you get results. You can see that the results are actually, if you do this with synthetic data, you see that the model, the learning algorithm, is actually able to pick up this, and it can be even used for forecasting. Like if you do forecasting with the learned state, you obtain forecasts that are much better than the alternatives. So the final thing that I want to tell you is this one about resharing, which is, I think, the best example of what I'm trying to convey. So let's consider resharing on a social media. So you have Twitter, you see a tweet, you decide to retweet it. Now it's called X, but I will ignore that. So you retweet this content, and when do you retweet it? Well, because it convinced you somehow. If you stop and think about it, this tweet can be of different topics. It can be about healthcare, like the first two examples here, or it can be about migration, for instance, in the last two. But even a tweet that has the same topic, like migration, in this can be retweeted by different groups of people. What does this tell us? That these two groups of people have a different opinion on that topic, and you can do this for every topic. So what we did is that we developed an agent-based model, like a behavioral model, that takes this into account by formalizing the concept that on the topic of a news, the two users that reshare this must be aligned. What you get out of this is, you need to devise the algorithm that, again, is just doing gradient descent on the likelihood of this model. And in the end, you get a model that is able to do predictions of what gets reshared, and it's a very good way to do embedding of a user that works better than Not2Vec, for instance. But the interesting fact is that it's giving us insight. If you look at the parameters that the model learned, those are not like uninterpretable embeddings that are very hard to get something from. Those are the positions of each user in another logical space. So, for instance, here you have the economy on the x-axis and the Clinton's emailgate. I hope someone remembers that when the email from Clinton got leaked and she was accused of corruption. And you can see that the different Reddit communities have a different positions on this axis. You have, for instance, the Donald is at the extreme is on the bottom left corner in both axes, while Democrats are extremely up, so extremely on the other side on the Emailgate scandals. But for instance, Bernie Sanders was a little less extremes on the Emailgate thing, but more on the economy. So this is a nice way to show that the parameters that this model is learning are very different from a neural network parameters. Those are parameters that you can interpret and that you can assign a meaning to. So I think my time is pretty much up. So I will go with the take-home messages that neural networks machinery, so Keras, TensorFlow, PyTorch, they can be used for things that are not deep learning and that are not neural networks, and that can be super interesting. That's I think a point in the direction of mixing the neural and the symbolic approach that was mentioned before. This way we can get something that is interpretable, which is super important, especially when you are answering real-world questions. That can be in biology, in health, but also in social sciences. And this is particularly important to me because it's clear that at least I believe that most of the most pressing challenges that we have right now are inherently social in nature. So yeah, thank you very much. And
Thank you, Corrado.
my fault.
No, thank you, Corrado, for the... No, it was me, probably in front of this. For the great talk. It's really fascinating how you can measure all this kind of stuff and talk about this also polarizing sometimes topics in a very clear and scientific way. So, who wants to go first? Who feels brave? Go ahead, Piero.
Thank you. So you talked about networks, and neural networks are made of neurons. There is connection, activity, plasticity. Also communities and societies can be thought as graphs. So to which degree in your experience we can push this analogy as a community being a cognitive system and vice versa?
That's super interesting question. Well, there are two sides of this question. One is from the more machine learning side. I mean, you have graph neural networks that are used to put where the neurons of a deep learning algorithm are actually points in a graph, and so you have connections with what the network is learning is how these are connected. So that's a very concrete metaphor, if you want. Of course, there is a more abstract way to put it, and the idea of the study that I presented about what is opinion changing is exactly that. How can social media be a bit more like the public sphere that we need to discuss and develop solutions to problem and convince each other of what's right and what's not. I hope that answers the hard question.
Okay, Andrea.
Yeah, I have a question more on the algorithmic side. The Trump model, when you have shown some positive and negative feature importances, maybe I missed that. Which model did you use in that case? It was a logistic regression or some...
I skipped a bunch of details, I know. That was a random forest. And what I showed you is a kind of sharp value, fundamentally.
Okay, so it was not...
No, we tried, we compared, we did that also with the logistic regression, which is the other natural choice that you can have. And the results are similar, slightly worse, so we opted for a nonlinear algorithm, which is a random forest. But yeah, results are very similar.
I was trying to find the reason for Raspberry Pi in first position.
That's true. Thanks.
That's a mystery that will stay with us. So who else wants to ask questions? Not only the speakers, but also the speakers if they want.
Well, okay. Thank you for your presentation. I got a question. I'm a Reddit user. So what I get is that when you're speaking in a subreddit or writing, there is a subset of people that they are in the subreddit. That brings us to thinking there is kind of a bias, right? Did you, if yes, if you encountered that, if you handle this, in which way? Thanks.
Yeah, that's something that we thought about. Actually, when I say participants, I literally mean people who commented or posted on that. And so we've been, let's say, conservative in the choice of users. You need to be a participant, so you need at least a comment in some of the studies, more than one, like 2. And we always put a threshold on the score. The actual definitions that we used to be rigorous for the Donald Trump research was that you needed a score, an average score of your comments on the Donald that was at least 2, something like that, which means that you are not only participating in the Donald Trump community, but you're also receiving a feedback from the other users in the Donald that is positive. So that make us quite sure that these users were indeed Trump users, Trump supporters. That answers your question? Yeah. Okay.
Okay, we have times for other questions. Yes.
Hi, thank you for your interesting talk. I was having a very out of curiosity question for this social behavior. Like I know of these butterfly effects that small events can like influence very big events. I was wondering, like in your studies, did you like worked on like why some of the posts or some of the people are going viral? Like how these are, like, can you say something about it?
Yeah, that's the $1 billion question, literally. Like, it's literally $1 billion question. Like, if you find out, you can get $1 billion easy. No, we tried to do something like that, and try to, but I mean, there are models that have been developed about like how to predict virality. There is a bunch of work on that. And I know that for images, for instance, that's very much related to the visual features of the image. So, for instance, the classic meme format, like a very drawing, very like easy with the text on the bottom. That's something that is like more likely to predict virality. Of course, there has been a bunch of theories about how much the emotional impact have a role in that. The most standard thing that is known in the field is that content that triggers emotionally is more likely to get reposted and so to get viral. So often anger can be a trigger. Like if something is making you angry, then you are way more likely to repost it, which is comprehensible. Like when you're angry, you are trying to change something, you are trying to convince other people, and that makes sense. Thanks for the question.
Yep. Stefano.
Thanks for your talk. You didn't mention anything about data pre-processing. So I assume you accumulate a lot of text, a lot of messages. Can you tell us a bit more that you're doing TF-IDF, all right? But how do you clean the messages that you're processing? How do you also avoid having the algorithm to misunderstand the sentiment maybe of a message? I don't know if you...
Yeah, I mean, we didn't use text that much in the sense that, for instance, for the LSTM one about opinion changing, there we use the standard pipeline, let's say. So we remove stop words, the tokenization is done. But now there are tools that basically make you like avoid even thinking about all that. Like if you go to JSIM and you look at the default and you find that everything makes sense naturally. So luckily, we live in a world where we don't need to think too much about that anymore. I remember at the beginning where you had to implement your own tokenizer, and it was a mess. No, apart from that, maybe the most uninteresting thing is that the Reddit dataset is huge. It's literally terabytes of text, which is a bunch of text. So you need to devise a pipeline that processes that in a way that is scalable. We used Spark for that, which makes it work decently without even too much of a hurdle. And so yeah, that's how basically we get from the original data set to like what we need. Which you ask about the sentiment. Sentiment. Every time we try to use sentiment in these works, turns out to be not predictive, which is interesting to me. At the beginning, maybe Alessandro, if he's in the room, remembers that my very beginning was in sentiment analysis. But yeah, I think that now we have even better methods in NLP. Thanks.
Yes.
Thank you for the presentation, first of all. I have a question. Since you analyzed the opinion changing model and the leverage that are used in the comments to make other people change their mind, don't you think that there is a hidden risk that discovering the leverages and the method, you can somehow develop a tool that can make changing the opinion of other people?
Yeah, no, for sure. Like that's something that we always think about. That even when you discover like tools to prevent the spread of violent content, then the discovery of such a tool puts a weapon in the hands of wants to spread those messages. With the opinions changing thing, I think it's a bit different, luckily. Mainly because what we find is are not tricks. Like it's not easy to convey knowledge in a message. Like for sure, ChatGPT can do it, and for sure, like if you know that this is the way, then you can generate more messages that are like that. But still, like I believe that still this lies in the agency of the recipient. Like it's still these are intents that increase the likelihood of a message being opinion changing, but that's not a sufficient condition to be opinion changing. If a message is transmitting knowledge, you are reading the message and you are trying to understand what knowledge is telling you, and if that convinces you. So I think I don't know. I believe in the in the human agency. Let's say.
Other questions? Yes.
Have you tried to apply these methods to Italian politics, or?
Yes. Yes. We did not exactly these methods, but we did a study on actually more than one on Facebook advertising, and especially on how Facebook advertising was used in political elections in Italy at first, and then we looked also at the rest of Europe. The most interesting thing about that we found is that the same political party can have like different targets. Like everybody is using targeting, like of course. Everybody knows that. And if you look at the demographic groups that is susceptible to messages of one party, you find that they are very demographically connotated. As I showed you, demographics is always undervalued in internet studies, but it's telling you a lot about the world. For instance, the average recipient of messages of Facebook advertising of Lega was much more likely to be male than female, and was much older than a user that was not targeted. The interesting fact is that sometimes you have different messages to different demographic groups. That's something that we saw. We studied the debate on migration policies in Facebook advertising, and you can see that there are like different ads with different stances that in the end, maybe not intentionally, maybe just because of how the Facebook algorithm works, but they arrive at different demographic groups. So the same people can be telling different things to different people, which is pretty scary. But yeah, thanks.
Other questions? This generated a lot of great questions and answers. I'll just add one. So getting data from social media changed a lot recently. Some social media got acquired and probably changed. Other social media changed the way you can gather data from the API. So what are the challenges in the data collection side? What has changed? And also how to address the fact that data from a social media changes distribution.
And that's the question. Like in every conference about computational social science, you go, and that's the topic that everyone, okay, now Twitter has basically closed down. Like they don't give you any data anymore, whether you are a researcher, whether you are a university, no care, you need to pay a bunch. Reddit changed their policies after OpenAI extensively used Reddit to train ChatGPT, and so that Reddit react to that by closing down their policies, and now someone says that their business model will be selling data to training neural networks. What to do? That's a good question. What we are doing in our group is trying to go and ask for research for like some companies that allows you to do research licenses to get their data from. There are not many at this point, but for instance, TikTok is one of those, and which is also interesting because that's a social media that is being extensively used and that a lot of people get a lot of information from. So I think that's interesting. We are applying for a research license on the TikTok. And let's see. There are also other alternatives like Mastodon, which are more open source and community driven. So like my hope is that will make them a bit more friendly to people who want to discover something about the world and not just make money.
Okay. If there are no more questions, let's thank the speaker once again.